All right, let's start with the section on trapezoids. We've done squares, rectangles, parallelograms, triangles. Now we're going to do trapezoids, and then we'll have some regular polygons next week. And that will be the rest of the polygons. And we'll move into circles and stuff like that. But for now, we're going to talk about area of a trapezoid. On your paper, I want you to sketch something for me. We're going to take this exact trapezoid right here. We're going to draw an identical trapezoid. We're going to flip it over and flip it over, and it's going to look like that. Okay, this trapezoid right here is the same as this one. I flipped it over, and then I flipped it over again, and it became this trapezoid. So, and then I'm going to put it right next to it. So draw it like that. Now, if I put two identical trapezoids together, what shape does it make? Another parallelogram, just like we did with triangles. You put two triangles together, you also made a parallelogram. This is just to show how we get our formula for the area of a trapezoid. To get the area of a parallelogram, my area of a parallelogram, actually, let me write it out. Area of parallelogram, just as a review, was base times height. Well, in this parallelogram, this is my base, and this is my height right here. I have my base all the way across the bottom, and then I have my height. So for this parallelogram, the base actually consists of the base number 1 plus the base number 2. Because you got a base 2 here, you got a base 1 here. The whole base all the way across the bottom is consisting of those two added together. So these two bases added together times the height would be my formula for this parallelogram right here. But I'm not looking for the area of a parallelogram. I want the area of a trapezoid. So I need to get rid of one of these trapezoids. So what do I need to do to my formula? Divide it by 2. That's going to be my trapezoid formula, written there or written down in here if you want. The area A of a trapezoid with bases 1 and 2 and an altitude of h would have the formula of your height times your two bases added together divided by 2. And I gave you the calculator-friendly version here, where you can instead of dividing by 2, you can multiply by a half or by 0.5. 0.5 times the height times the base 1 plus base 2. So that would be our area of a trapezoid. Now, it also works for right trapezoid. If I have a right trapezoid, take a look at here. Now, notice my base 1 and base 2. My base 1 and my base 2 have to be parallel. If they're not parallel, then we call them legs. This side over here is a leg, and this side over here is a leg. These are two legs right here. This is a leg on this side. So you have your leg on both sides. Your bases are the parallel. It can't have two pairs of parallel sides, otherwise it's a parallelogram. It's not a trapezoid. Trapezoids only have one pair of parallel bases. So if you look at a right trapezoid, you've got right angles here. If I was to do the same thing I did up in this picture up here, then I would make another one over here. Guess what shape I'm going to make this time? A rectangle, because of the right angles. I'm making a rectangle because I have right angles on this one. It would be a rectangle. You're still going to have base 1 plus base 2 would give you the whole base times your height, and then you divide it by 2 to get the trapezoid. What was the area formula for a triangle? Base times height over 2. Area of a trapezoid kind of sounds a little like triangle, because TR and TR, trapezoid triangle, is bases times height divided by 2. Almost the same, base times height divided by 2, bases times height divided by 2. Same scenario, and both triangles and trapezoids can be made into parallelograms if you make another congruent one. All right, so there's slide number 1. Moving on. Oh, let me do the math, Captain. Moving on. Here we go. Okay, here's our first example. The challenge here is to resurface a parking lot. So the parking lot is in the shape of a trapezoid. You can imagine all the little parking lines that you'd have for the cars and everything like that. The cost to resurface the parking lot is $1.75 a square foot. It says, what will be the total cost of resurfacing the lot? Is it asking me for the area of the lot? No, it's asking me for the cost, but how would I find the cost? I gotta find the area. So the first step that I need to do is to find the area so that I could convert that into a total cost. To find the area, I need to use my area formula. Now I like to rewrite it a couple of times, so the first 2 or 3 examples you'll be seeing the formula written again, just to help you get it into your head. It's the bases times the height divided by 2. So in this case, my bases are the 800 and the 1200 because those are the parallel ones. 800 and 1200 times the height, which is 447, not 490. 490 is your slant height. You need the height that has the right angle, so you got to have the 447, and then divided by 2. Now it's just algebra. You just put your 800 and 1200 together, you multiply these two and divide it by 2. Your square footage of the parking lot is 447,000 square feet. Now, if each of those square feet costs you $1.75, or in this case, it would cost the city $1.75 because they're the ones that resurface parking lots usually. Could be the owner of the parking lot. To find the total cost, we need to multiply the 447,000 by $1.75, $782,250. You can see that cities don't generally like to resurface things a lot unless they really need it, because it does cost quite a bit of money to resurface, stuff, because parking lots are large. You measure parking lots, and they're pretty good size. So, $782,250 would be the cost, total cost. So first step, we had to find the area. Second step, we had to find the total cost. Good to go? Okay, good. Here. This is a comma right in here, yeah. $782,250. Okay, photovoltaic cells convert solar energy into electrical energy. If you notice the solar panels that we have in our parking lots, they're full of these photovoltaic cells. They collect the solar energy, they convert it to electrical energy. The cells completely cover the solar panels. Now this is one solar panel. Okay, it has the shape of a trapezoid. It's got bases of 2.3 feet and 1.7 feet. The solar cells can generate 8 watts per square foot. So 8 watts for every square foot on here, that's what it generates. If 40 watts is required from each panel, what must the altitude for this panel be? Now notice where the altitude is located on this panel. Why is the altitude going sideways this time? Because my bases are where? The two sides are my bases. These are the ones that are parallel. You can put little arrows right here showing that these are the parallel sides. Therefore, my altitude makes a 90-degree angle with those bases. So there's my height. It's just basically a trapezoid we turn sideways. So the first thing we need to do is we can let A represent the area. We don't know the area of that yet. We do know how much output of watts it gives us. It gives us 40 watts. We do know that it gives us 8 watts for every square foot. So we got to find out what the area is. So what we're going to do is we're going to use the formula to solve for the area. The formula that we're going to use would be total power equals power per square foot times solar panel area. So if I know how much every square foot gives as an output, and I know how many square foot there are, I can multiply them together and get the total power. What two numbers did they give us out of these three? They gave us the power per foot, which was 8, and they gave us the total power, which was 40. So they gave us these two numbers. 8 times something has to give us 40 watts. You probably know in your head what the area has to be now. If I plug in 40 and an 8 and an A, because my area stands for A, my power per square foot is 8, my total power was 40, so 40 equals 8A. If I divide by 8, my area is 5 square feet. That's the area. Area 5 square feet. Now think about how that works. If I have 5 square feet, and each square foot is 8 watts, then how many watts is coming out of that panel? 40 watts, which is what they told us right there. So that area has to be 5 square feet. So that means the area of this trapezoid is 5. Area is 5. I got the two bases. Can I solve for h? So I need to use my formula. I need to use my formula so I can solve for h. My formula here is my bases times my height divided by 2. My two bases times it by the height divided by 2. This time I'm going to take out the a and put in a 5. Because my area I just found out was 5. I'm going to leave h in the problem because I don't know what h is. I'm trying to solve for h. My two bases are 1.7 and 2.3. Those are in the picture over there. Those are my two bases. And then divide by 2. What's the first thing I would need to do to solve that? What would be the first step in solving? Multiply both sides by 2 so that I can get rid of this dividing by 2. I don't want the dividing. So that's what I did here. I multiplied both sides by 2, and I got 10 because 5 times 2 is 10. The 2's canceled out. I added these two together and got 4 times h, so 4h. And then I divided by 4. I divided by 4 and I got h is 2.5. So 2.5 feet would be my height. So I can even write that in over here if I wanted to. H is 2.5 feet. Now if I use this height and these two bases and I found the area, my area would be a 5 because I solved for that already. I got 5. Moving on. Okay, page 4, probably on your back side. It says find the area of a trapezoid with vertices at these 4 points. So plot those 4 points and see what you get. I bet I can plot mine faster than yours. Ready, mark, set, go. I win. Sorry. I'm a speed plotter and I'm a speed drawer there, so got you guys. All right, so you want to find the area of that trapezoid. Now, as you're drawing it, decide if you think it's an isosceles trapezoid or not. Isosceles trapezoids would have 2 legs that are the same. 2 bases are parallel, the 2 legs are equal in an isosceles trapezoid. So see if you think that's isosceles. As you draw it, does it look isosceles, or do you think it's isosceles? No. Well, it's not, because if I look at this point, to get to this point, I have to go over 4 and up 4. To get from this point to this point, I go over 3 and up 4. If they were the same, it would be over 4 and up 4. Then it would be isosceles. That's not, but we can still find the area. Right now, I know that my base 1 is 5. My base 2 is 12. And my height, which goes straight up and down, is easy to find on a coordinate plane because you can just count 1, 2, 3, 4. So my height equals 4. Now let me ask you one question. Does my H1 have to be 5 or could H2 be a 5? Do I have, I mean, my B1, sorry. My B1 have to be a 5 or does B2 have to be 12 or could I switch those two? I can switch. It doesn't matter which base. You just need to add the two bases. My general rule for me is I usually make the smaller one base 1, but it doesn't matter. You could make either one. You could make always your top one base 1. And in this case, then it would be a base 1 of 12 and a base 2 of 5. So it doesn't matter. Now you need to plug it into your formula. So you've got your 5 times your 12, your two bases, times your height, divided by 2. Add your two bases, times it by your height, divided by 2. That'll give you the area. So you're going to get 17 when you add the 5 and the 12 together. You get 17 times 4. And then you get 68 divided by 2. 34 square units. 34 square units. So the tricky part in some of the practice ones that we're about to do is we have to find the height. Usually the bases are given to you, but not always. But finding the height's hard. Now on a coordinate, finding the height's easy because you just count straight up and down. It's got to be perpendicular. If your bases are horizontal, your height's going to be vertical, and it's going to be easy to find. Just when they're not given to you, that makes it a little tougher. Good to go? Okay, practice problems. Let's look at number 1 first. I'm going to have you draw a vertical line straight down right there. And that's going to represent our H. Okay, we don't know that height. It's not given to you, but we could figure it out. We do have enough information because what kind of a triangle did I just draw? A right triangle, and it's a special one. 45, 45, 90. So that means that this is also 45 up here. And what do I know in every 45, 45, 90, what do I know about their legs? The two legs are equal, right? This leg has to equal this leg because of the angles both being 45. So put your tick marks in there to show that those two legs have to be equal to each other. Do I know the length of those legs is the question. Well, let's see. If I bring another vertical down, this piece is 8, right? I know that these are both 45, so this is also going to equal. These two are also going to be the same thing. So if I take 20 and subtract 8 from it, I get 12 left over. If I divide that by 2, what do I get? These are both 6. So both of these have to be 6. So now do I have enough information to get my area? Yes, I have my bases. Times it by my height, I divide it by 2. So area would equal my two bases together, 8 plus 20, times the height, which is now 6, and divided by 2. 28 times 6, divided by 2, 48. 168 over 2 is 84 square feet. So sometimes we have to work for the height. And normally you can always bring down a right angle, so you got your right triangle that you can figure it out. It's the same scenario for this one. Again, we need to bring a 90-degree line straight up. We need to put in a right angle box, because this is a right angle here. Our triangle, we have a right triangle. What kind of special triangle do I have in this one? Yeah, 30, 60, 90. Now I want you to label the three sides of my 30, 60, 90 as far as the words go. We know what this longer side is right here. What is this longer side called? Hypotenuse. Okay. Do we know what this height is going to be called as far as my three sides are concerned? Which leg? Short leg, because it's across from the shortest angle. has to be the short leg. If it's across from the shortest angle, it's the shortest leg. This 60 up top has to be now the longer leg. Do we know what, first off, that this 6 comes straight up and it's going to give me a 6 right there. So this is 6. So what does my longer leg have to be? Got to be 14, because we know they have to add up to 20, so this longer leg equals 14. 14 plus 6 does give me my 20. Little shortcuts. I don't know if you remember it or not, but the short leg times it by radical 3, you get your longer leg. Remember 30, 60, 90, 3 angles, so radical 3. Take your short leg, times it by radical 3, you get your long leg. This time my long leg is 14 though. I need to go backwards and get my short leg. How do I get short leg by itself this time? Divide by radical 3. So your short leg equals your long leg divided by radical 3. My long leg is 14, I divide it by radical 3. 14 over radical 3 is not really allowed though. And what I do to get rid of that radical from the bottom? Times both sides, top and bottom, by radical 3. 14 radical 3 over 3 is actually our height. I don't like it as that fraction, so I'm going to make it a decimal. Some calculators, you can try your calculator and see if yours will work. Some calculators will allow you to divide these two right away. It'll take this one will, by the way. You could take 14, divide it by the square root of 3, and hit equals, and you'll get 8.1 right off the bat. So I wouldn't have needed to do any of this stuff down here at the bottom. None of this I would have needed to do, because my calculator would give me 8.1 right away. Some calculators, you put that in, it's going to give you an error, it won't do it. So then you'd have to take this part and do 14 times the square root of 3, and then divide it by 3, and you still get 8.1. The exact same answer. So either way, you get 8.1 for your height. It's just a matter of what your calculator will do and what it won't do. Now that I've got the information for my area, I can take my bases, 20 plus 6, times it by my 8.1, and divide it by 2. So 20 plus 6 would be 26, times it by 8.1, and then divide it by 2, you get 105.3 square inches. And this is all I would need on your worksheet. To show me where you plugged it in the formula and then use your calculator and give me your answer. I would like to see some of this stuff where you drew on your pictures, just so you know how to get the height. That lets me know that you're trying to figure out what the height is. But at least plugging it in and then doing it on here and then giving me the answer would be fine. Now the bottom one also needs a 90-degree angle. We'll bring a line straight up from the bottom and put a little right angle box. And this one, again, there's one of these or two of these on your homework. That's not a special triangle. It is a right triangle though. And what always works in right triangles? SOHCAHTOA. Remember our Indian chief? Right triangles, he loves right triangles. So this 50 degrees is across from the opposite side, which is my H. That's what I need to find. This is my adjacent side. This is my hypotenuse. Out of those two sides, adjacent and hypotenuse, what side do we have? What side did they give us? They gave us adjacent. Not yet, but we can figure it out. They did not give us hypotenuse, so we don't need that. We do need to figure out the adjacent. Anybody know what the adjacent is? 7. That's right. Let's see how she got it. This has to be 7 right here. It's 7 because what's 36 minus 22? Yeah, 36 minus 22 is 14. So these two pieces have to add up to 14, and they have to equal each other because they're both 50-degree angles. So they both must be 7s. Because 7 plus the 22 would give me the 36 on the whole top. All right, so SOHCAHTOA. Here's my 50 degrees. There's my O. I have an O, and I have an A. OA. SOHCAHTOA. Gotta be TOA, right? Gotta be tangent. So we're going to do tangent of 50 equals my opposite side H, that's my height, over the 7. Multiply both sides by 7. So your H is just going to be 50 times the tangent of 50 times 7. So H equals 7 times the tangent of 50. Let's see what we get when we do that. 7 times tan of 50. In your calculator, you should get 8.3 when you round it off. So my height, 8.3 is my H. Now do we know how to find area? Do I have both bases? Do I have height? Yes, now I can find area. So base 36 plus base 22 times height of 8.3 divided by 2. That's my area. I plug all that into my calculator. And that's why you don't have to show any more work after you've plugged it into your formula, because now you can do it all in your head. 36 plus 22 first. That's 58. You're going to times that by 8.3. And then you're going to divide that by 2. You get 240.7. 240.7, and in this case, it's square centimeters. Square centimeters. Page. These last few are pretty quick. The area of a trapezoid is 225. Altitude is 10. The base is 30. Find the length of the shorter base. All I'm going to need is my formula. A equals base plus base times height divided by 2. Let's plug in what we know. What is it that they gave us? They gave us the big A, so that's 225. What else did they give us? Did they give us H? That's 10. Did they give us my two bases? They just gave me one. So they gave me one of these two B's, so I still have one missing. I could put 30 plus B, or I could put B plus 30 there. It's the same. You'll get the same answer. And then we divide by 2. All I have to do now is solve for B, because I have my other base. What's the first step? Multiply both sides by 2. That's going to cancel out those 2's, and they're gone. Multiply 2 times 225 and get 450. I would distribute the 10 right now, so you don't have to worry about bringing it down. You'll have 10B plus 300. Subtract your 300. And you'll get 10B is 150, because these 300s will cancel. And then when you divide by 10, B will be 15. So your shorter base is 15 meters. Your longer base was 30 meters. Your shorter base was 15 meters. So those would be your two bases. Trapezoid has one base that is 8 centimeters longer than the other base. The height is 3, the area is 24. Find the length of both bases. All right, we need our formula again. So A equals base plus the base times the height divided by 2. What did they give us? Again, they gave us area, which is 24. Did they give us H? Yeah, 3. Did they give me my bases? No. Neither base. So I just put B plus B? B plus 2B? Is it what? 8x plus B? 2B plus 8? B1 plus B2. Okay, so let's pretend that my first base is x. Okay, so my second base is 8 more than that. Not 8 times that, 8 more than that. It's x plus 8. You were right. It's 2x plus 8. because you're going to end up with two x's when you combine your like terms. One base is here, x, the other base is x plus 8. When you combine them, you're going to get 2x plus 8. But first thing, let's multiply both sides by 2 so we can get rid of that fraction. You get 48 equals, and let's distribute the 3 to the 2x plus 8. That's going to give you a 6x plus 24. And then subtract your 24, yeah.
How did you get 8?
Because it says that one base is 8 longer than the other.
Okay.
So if one is x, the other one is 8 more than that. So it's 8 plus x, or x plus 8. So that's going to give us 24 equals 6x, and x is going to be 4. So my bases, it's asking for both bases. We know one of them is a 4. What's my other base then have to be? 12. Got to be 8 more than that. So that's 12. So 4 and 12. High school is building an athletic field in the shape of a trapezoid. What length fence will be needed to enclose the field? So they got to buy some fencing to make it so that the footballs and soccer balls and all that stuff doesn't fly into the street. So what length of fence would they need to buy? How do I figure that out? Find the perimeter. And did they give me all 4 sides? Add them up. So over here we'll put perimeter equals, and then we'll list our 4 sides. 175 plus 195 plus 300 plus 150, and it equals, I think, 820. Yeah, all right. 820 yards for a fence. So 820 yards. Now, fencing material is not just the chain link, but you'd have to buy posts, cap, hooks that hold it on, and all kinds of stuff that you'd have to buy. But that's how much square yard, or yards, not square yards, just yards that you'd have to cover. The last one is asking us for how much square yards of sod would they need to use to cover the field. So they want to plant sod here. They want to make it nice, good grass right off the bat. So they want to know the area of that. So let's see if we can figure out the area of the field. Now, it looks to me like they gave me all the information I need, because these are right angles right here. So this is my height. In a right trapezoid, that leg where the right angles are is where the height is, since the height and the bases are always perpendicular. So you know that your bases are 175 and your other base is 300. You're going to times it by the height, which is 150, and divide it by 2. So you're going to need quite a bit of sod. Check my math, but I think it's 35,625 square yards of sod that they would need if you plugged all that into your calculator. So you add your 2 bases. Here was base and a base. Your height is where the 90-degree angles are, and then you divide by 2.